In this video, we're going to complete example 2. We're going to sketch the following graphs by first completing the square. Now, I would just like to point out that we're going to be completing 4 questions. Here we have question A. We're going to finish on question D. Let's start with question A. We've been asked to first complete the square. Now, we already looked at this equation back at example 1. And rather than going through the whole process of completing the square again, let's just copy down the result we got back in example 1. We came up with y equals x minus 3 squared minus 4. So when we complete the square, we get an equation in the form y equals a x minus h squared plus k. From this we learn that a equals 1, because if there's no number to the left of the brackets, technically there's the number 1 there. We also have h, which equals 3, and k, which equals negative 4. Now our vertex can be found from our h and k values, meaning that our vertex is the point 3, negative 4. Now the vertex is only one of the 5 things that we need to find. And in case you've forgotten what we need to find here, we need to find the direction of the parabola, whether it's upward or downward facing, the y and x-intercepts, the axis of symmetry, and the vertex. Now, as I mentioned, we already have the vertex. The vertex is the point 3, negative 4. And when we know the vertex, we also know the axis of symmetry. We simply take the x value of 3. The axis of symmetry will be the equation x equals 3. Now to find the direction of the parabola and the y-intercept is really easy if we look at the original equation here. Looking to the left of x squared, we can see that it's positive, meaning it's an upward facing parabola. We can also see that we have the constant plus 5 at the end, which means that our y-intercept will be the point 0, 5. The last thing we need to find are the x-intercepts. And we can take either of these 2 equations here and just make them equal 0. It's going to be faster to find the x-intercepts if we take the equation where we completed the square. So we take the equation x minus 3 squared minus 4 and make it equal 0. Now what we need to do is add 4 to both sides of the equation. We now have x minus 3 squared equals positive 4. Next, we square root both terms. And what this will do is it will cancel out the square, leaving us with x minus 3 on the left. Now on the right, when you square root 4, you get 2. Now I need to point out that we actually have 2 solutions here. It's either positive 2 or could also be negative 2. The reason it can be either positive or negative is because if I square either positive 2 or negative 2, it will take me back to positive 4. It actually helps if we write them as 2 separate solutions. So x minus 3 can equal positive 2, and x minus 3 can equal negative 2. Looking at the first equation, I'm going to add 3 to both sides. This will give me a solution of x equaling 5. And for the second equation, once again, I'm going to add 3 to both sides. This will give me a solution of x equaling positive 1. I now have the 5 things that I'm looking for, which means I can now graph my parabola. Now when you sketch this graph, you want it to look like it's been drawn to scale, but you don't want to spend too much time on this. So we'll start on the x-intercepts, 1 and 5. I'm going to pick the following 2 points, 1 and 5. I'm going to label them as the points 1, 0 and 5, 0. Now you may have noticed when I picked these 2 points, I didn't spend too much time on it. I didn't bother to count the squares. All I wanted is 2 points that look like they've been drawn to scale. Next, I'm going to label my y-intercept 0, 5. I'll label it here, 0, 5. We also need our axis of symmetry, which is the equation x equals 3. We know that the axis of symmetry will occur halfway between the two x-intercepts. So here's my axis of symmetry. We'll also label our vertex, which lies on the axis of symmetry. It's the point 3, -4. 3, -4. We now have enough information to draw our parabola. We're just going to draw our graph passing through the points we've labelled, making sure that the turning point occurs at the vertex. Now, some of you may have noticed that we really did need all these points labelled, but one thing we probably didn't need was the axis of symmetry. And if you don't put the axis of symmetry in, that's actually okay. The main things that are required are the vertex, the x-intercepts, and the y-intercept. Anyway, let's now move on to question B. The first thing we need to do is complete the square. We look at the number to the left of x. It's the number 8. We need to halve that number. So half of 8 is 4. And then we square our 4. 4 squared equals 16. So we want 16 to be at the end, not 13. So we'll fix that by taking our function and rewriting it as x squared plus 8x plus 16 minus 3. And that's because 16 minus 3 is the same as plus 13. Now we're going to look at what's underlined in red, and we're going to complete the square here. We're going to get x plus 4 squared. And we know that because half of 8 is 4 and 4 squared is 16. Now we have the minus 3 at the end, so that just carries down. We now have f of x equals x plus 4 squared minus 3, which has been written in the form a x minus h squared plus k. So we can see that a equals 1. Not that that really matters. We don't need to figure out a. We know that h is going to be -4. H will equal -4. Because if I replace h with -4, I get x minus -4. That's the same as x plus 4. And we can see that k will equal -3. That means our vertex is the point -4, -3. After finding the vertex, I'm now going to find my x-intercepts. Those are the two difficult things to find, the vertex and the x-intercepts. Out of these two equations, I'm going to take the one where we have completed the square. So I'm going to take x plus 4 squared minus 3 and make this function equal 0. To find the x-intercepts, you need to make the function equal 0. So we'll start by adding 3 to both sides. We get x plus 4 squared equals 3. We then square root both of our terms. This will cancel out the square and leave us with x plus 4 on the left. Now the right will remain as the square root of 3, because if I work out the square root of 3, I'm going to get a nasty decimal. In fact, let's look at what we'll get. We get about 1.7. I might as well write that down. It's approximately equal to 1.7. We don't really like approximations, which is why we keep it as the square root of 3. Now you might remember we actually have two solutions here. It's actually plus or minus the square root of 3. The same with our 1.7. It's plus or minus 1.7. It helps when we write both solutions separately. I'm just going to give myself a bit of room here. So our two solutions are that x plus 4 equals positive root 3, and x plus 4 equals negative square root 3. Focusing on our first solution, if we subtract 4 to both sides, we get x equaling the square root of 3 minus 4. For the second solution, once again we subtract 4 to both sides, and we find that x will equal negative root 3 minus 4. Now, as I mentioned before, we like to leave our solutions with the square root sign so that we have an exact solution. But what we're going to do is we're going to look at what it will equal as a decimal. And there's a really good reason for that. It just helps us when we need to graph those points. So root 3 minus 4. Root 3 minus 4. That equals about negative 2.3. So that's approximately negative 2.3. And then we had negative root 3 minus 4. So negative root 3 minus 4 gives us negative 5.7. So we'll write that down. It's approximately negative 5.7. So we give our solutions using the square root sign, but we also write down our decimals just to help us graph them on our xy plane. You might remember there are 5 things that we need to find. We know what the vertex is. The vertex is the point negative 4, negative 3. We have our 2 x-intercepts down below. To be honest, we don't really need our axis of symmetry because we have our vertex. If we look at the very first equation, we were adding the constant 13 at the end. That means that our y-intercept is the point 0, 13. Looking to the left of x squared, it's positive, so it's an upward facing parabola. So I'm going to label my y-intercept first. I'll label it up here as 0, 13. Remembering that we pick a scale that allows us to sketch the graph quickly and neatly. When I plot my x-intercepts, I'm going to look at the decimal. I have negative 2.3, so I'll plot that here. But when I label it, I'm going to label it in exact form. Root 3 minus 4, 0. So we use the decimal to help us plot the point, but we use the exact form when we label that point. I also have negative 5.7. I'm going to plot that here, but I'm going to label it as negative root 3 minus 4, 0. Next I have my vertex. I'll put that down here as the point negative 4, negative 3. Make sure that your vertex is halfway between the 2 x-intercepts. As I mentioned before, you don't really need the axis of symmetry because it just passes over the vertex. Right, let's now sketch the graph, making sure that the turning point occurs at the vertex, like so. Let's now move on to question C. Now we had this same function back in example 1, and when we completed the square, we got f of x equals x plus 1.5 squared plus 0.75. This function is in the form a x minus h squared plus k, meaning that h will equal negative 1.5 because x minus negative 1.5 is the same as x plus 1.5, and k will equal positive 0.75. So we now have our vertex taken from the h and k values, which will be negative 1.5, 0.75. Let's also find our x-intercepts. So we'll take our function after completing the square, which is x plus 1.5 squared plus 0.75, and we'll make it equal 0. We then subtract 0.75 on both sides of the equation. This will give us x plus 1.5 squared equals negative 0.75. Alright, now I need to give myself a little bit more room here. What I'm going to do next is I'm going to square root both terms in the equation. This will cancel out the square, leaving me with x plus 1.5 on the left, and then the square root of negative 0.75 on the right. Now, some of you might have noticed something quite interesting here. We are trying to square root a negative number. And when I try to do this on the calculator, I'm going to get an error. So what do we do in this situation? Well, this means that there's actually going to be no solutions, or no x-intercepts. So I've just written a comment that x-intercepts do not exist for this function. So how am I going to draw this graph? Well, I do know what the vertex is, so I'm going to label that right here. This is the point at which x is negative 1.5 and y is 0.75. I can also find my y-intercept really easily. Looking at the original function, we can see we're adding the constant plus 3. So my y-intercept must be this point here, 0, 3. I'd like to remind you of the 5 things we look for when we try to sketch a quadratic. We have our y-intercept, which is 0, 3. Our x-intercepts do not exist. Our vertex is the point negative 1.5, 0.75. Our axis of symmetry can be taken from the x value of our vertex, negative 1.5. So our axis of symmetry will be the equation x equals negative 1.5. When I draw the axis of symmetry on my graph, it will be a vertical line or vertical dotted line passing through the vertex. And the other thing I can find here is the direction of my parabola. Looking to the left of x squared, I can see that it's positive. So it's going to be an upward facing parabola. Now I know that my parabola will be symmetrical over the axis of symmetry. So looking at my y-intercept here, I can put another point which is symmetrical to that point over the axis of symmetry. I now have 3 points, which is all I really need. So here's my parabola, and we can see that it doesn't cross over the x-axis, hence why we didn't have any x-intercepts. Anyway, let's now move on to question D. We first need to complete the square. So we're going to look at that number to the left of x, negative 12, and we're going to halve it. We get negative 6. Now when we square negative 6, we get 36. This is one of those rare cases where our function was already a perfect square. So when I factorize it, or when I complete the square, I'm going to get x minus 6 squared. We take the x from the x squared, and we take the negative 6 by halving the negative 12. So our function is in the form a x minus h squared plus k. We can see that h equals 6. But what does k equal? There's nothing being added here, which actually means we're technically adding 0. So k equals 0. That means our vertex must be the point 6, 0. On our Cartesian plane here, we'll label that point as 6, 0. So let's look at the 5 key things that we need to find in order to sketch the parabola. We know our vertex is the point 6, 0. Our axis of symmetry is always taken from the x value in the vertex. So the equation for the axis of symmetry will be x equals 6. I'll draw the dotted line, but you don't really have to draw the axis of symmetry every time. Alright, what about our y-intercept? Looking at the original equation, we have plus 36 at the end. So our y-intercept will be 0, 36. We'll draw that on our Cartesian plane. 0, 36. When we look to the left of the x squared, we can see that it's positive, meaning that this is an upward facing parabola. Now we know that our parabola will be symmetrical over the axis of symmetry, which means that there must be another point over here. This point is symmetrical to the y-intercept. Now, do we really need to find the x-intercepts? Some of you might notice that we've got all the information we need to sketch our parabola. It's going to look like this. So why is it that we didn't need our x-intercepts? Well, we actually only have one x-intercept, and it's this point here, which is the same as the vertex. So I could write my x-intercept down, but I had already labelled it when I labelled the vertex. Anyway, that concludes example 2. Remember to read the description below for links to workbooklets that relate to this video.